Silence sits between two magnets, calm and still, almost like nothing is happening at all. Yet that quiet space hides a powerful story that most people never notice, because even when your eyes see emptiness, physics is busy at work there every second. Right now, two solid objects are pulling or pushing each other without touching, and the real question is simple but deep at the same time. It looks empty, but what is really between these magnets? Many people think the answer is nothing at all, just air, just space, just a gap that does not matter. But that idea is wrong, and today's video is about uncovering what truly exists in that invisible zone. Magnets are not magic objects, even though they often feel like they break the rules of nature. A magnet is simply a material that can create a force that can attract or repel other magnets and certain metals. This force does not stop at the surface of the magnet. It spreads outward into the space around it. That surrounding area is called a magnetic field. You cannot see it with your eyes, you cannot grab it with your hands, and you cannot trap it in a box, but it is real, measurable, and strong enough to move solid objects. The space around a magnet is not empty, space doing nothing. It is an active region filled with influence. Think about wind for a moment. Wind has no shape, no color, and no solid form, yet it can bend trees, push clouds, and move entire ships across the ocean. You only know it is there because of what it does. A magnetic field works in a similar way. You do not see the field itself, you see its effects. When two magnets are placed near each other, the fields around them begin to interact, overlap, and reshape the space between them. That space becomes a battlefield of forces, lines of influence stretching, bending, and sometimes canceling each other out. In this video, you will learn what fills that hidden gap, how magnetic fields really behave when magnets face each other, and why attraction and repulsion happen without physical contact. You will also learn why the space between magnets can sometimes be stronger than the magnets themselves, and how this invisible force plays a role in everyday technology, from simple fridge magnets to advanced machines that power cities. There are details here that rarely get explained in simple language, details that change how you look at space, forces, and even emptiness itself. By the end of this video, the idea of empty space will never feel truly empty again. Stay until the end, because we will connect this unseen force to real-world effects that quietly shape modern life, often without anyone noticing. Welcome to our channel, where unseen science becomes clear and simple, and if you enjoy learning the hidden truth behind everyday things, make sure to subscribe and stay with us for more stories like this. A magnetic field is not a thing you can hold, cut, or store on a shelf, and that is where most confusion begins. It is not made of atoms, it has no weight, and it does not take up space in the way solid objects do. A magnetic field is better understood as a region where a force exists. When a magnet is present, the space around it changes. That space gains rules. Objects entering that space may feel a push or a pull, even if they never touch the magnet itself. This is why the magnetic field is called a force region. Inside this region, magnetic forces can act. Outside it, those forces fade away. The magnet does not send out tiny pieces of itself. Nothing flows outward like liquid or gas. Instead, the magnet creates conditions in space that allow force to appear. Scientists use the idea of field lines to describe this invisible structure. These lines are not real strings floating in the air. They are drawings, a tool to help the human mind understand how the force behaves. Field lines always leave the north side of a magnet and curve through space until they enter the south side. This direction matters. It tells us which way the force would push or pull another magnet or a piece of metal. Where these lines are close together, the magnetic field is strong. Where they spread apart, the field is weak. Even though no one can see a magnetic field directly, its shape can be revealed. When tiny iron particles are sprinkled near a magnet, they line up along the invisible paths of force, turning something unseen into a visible pattern. This simple effect shows that the space around a magnet is highly organized, not random, not empty, but structured and active. When two magnets move close to each other, the situation becomes more complex and more interesting. Each magnet brings its own magnetic field into the space, and these fields do not ignore one another. They interact, they bend, merge, and sometimes fight for control of the space between the magnets. The real action is not happening inside the magnets alone. It happens in the space between them. When the north pole of one magnet faces the south pole of another, the field lines from the first magnet naturally flow into the second. The lines leave the north pole, cross the gap, and enter the south pole directly. This creates a dense bundle of field lines between the two magnets. The space between them becomes filled with strong magnetic influence. This is why the magnets pull toward each other. The force feels natural and smooth because the fields are working together, not against each other. The magnets are not chasing one another. Instead, the magnetic fields are forming a stable pattern that lowers the energy of the system. The magnets move closer because the field prefers that arrangement. The attraction you feel is the system trying to settle into balance. As the magnets draw nearer, the field between them grows stronger. The invisible lines become more crowded, the force increases, and the pull becomes harder to resist. This strength does not come from physical contact. It comes from the structure of the magnetic field in the space between the magnets. Even a small gap can hold a powerful force. This explains why magnets can snap together suddenly when they get close enough. The field between them reaches a point where it dominates the motion. The space becomes more influential than the air, more important than gravity in that moment. This same idea is used in many machines where parts move without touching, guided only by magnetic fields. The story changes completely when like poles face each other. When north faces north or south faces south, the field lines no longer want to connect. Both sets of lines try to leave the same type of pole or enter the same type of pole. The directions clash. Instead of flowing smoothly from one magnet to the other, the field lines bend away, curve outward, and avoid the central space. The result is a region between the magnets where the field becomes weaker. The space is still not empty, but the forces there are competing. This competition creates repulsion. The magnets push away from each other because the field arrangement between them is unstable and high in energy. The system tries to reduce that energy by increasing the distance between the magnets. As they separate, the conflict between the fields becomes less intense. In some arrangements, this opposition can create a special point in space where the magnetic forces cancel out. This is sometimes called a null point. At this exact spot, the pull from one direction is balanced by an equal pull from the opposite direction. The net force becomes very small or nearly zero. This does not mean the magnetic field is gone. It means the influences are balanced. Just a small movement away from that point brings the force back. This delicate balance shows how precise and structured magnetic fields can be. Even in repulsion, the space between magnets is filled with invisible order. As the magnets shift position, the field reshapes itself instantly. The field responds faster than any mechanical system could. There are no delays, no gears, no signals traveling through wires. The change in position changes the field pattern, and the forces adjust right away. This responsiveness is one reason magnetic fields are so useful in technology. They allow motion and control without friction. The space between magnets becomes a working zone, a place where forces are guided and shaped without contact. The idea that the strongest action happens in empty space challenges how people normally think about forces. We tend to believe that objects must touch to interact. Magnets prove otherwise. The interaction lives in the field. The field belongs to the space around the magnet as much as to the magnet itself. When two magnets face each other, the space between them is transformed into a structured environment full of direction and strength. Whether the magnets attract or repel depends entirely on how their fields fit together. The magnets simply follow the rules written into that invisible structure. The space between magnets often feels empty because human senses rely on sight and touch, and neither of those can detect a magnetic field directly. When you look between two magnets, nothing blocks your view. No mist, no glow, no moving particles appear in the air. Your hand can pass through that space freely, without resistance. This creates the strong illusion that nothing is there at all. But the absence of visible matter does not mean the absence of influence. The magnetic field continues to exist whether it is noticed or not. It fills the region quietly and completely. This is similar to the way air behaves. Air feels like nothing most of the time. You walk through it without effort. You rarely think about it as something real, yet air has pressure. It pushes on your skin. It carries sound. It creates wind strong enough to shape landscapes. The same idea applies here. The magnetic field does not need to be seen to be active. It does not need weight or color to affect the world. It works silently, shaping how objects move and interact within its reach. The magnetic field is not spread evenly like a flat blanket. Its strength changes from point to point. Some areas are dense with influence, while others are weaker. The space between magnets can be one of the most active regions of all. When two magnets are positioned near each other, their fields overlap in that gap. That overlap turns the space into a zone of action. Forces rise there. Directions become defined. The field tells objects how to move before they ever touch anything. This is why a magnet can pull another magnet or a piece of metal from a distance. The field reaches out first. The object responds by moving along the invisible rules written into that space. This hidden activity becomes easier to understand through simple everyday experiences. A fridge door offers one of the clearest examples. Small magnets hold notes and photos in place without glue, without hooks, without pressure from screws or nails. When you place a magnet against the fridge, the pull feels immediate and firm. The magnet snaps into place as if guided by an unseen hand. What actually happens is the magnetic field from the magnet interacts with the metal in the fridge door. The space between them becomes charged with force. That space may be thin, but it is doing all the work. Even before the magnet touches the surface, it is already being pulled in. The force increases as the gap shrinks. Once attached, the magnet stays in place because the field continues to hold it there. Nothing visible connects the two objects. The connection exists entirely in the invisible field between them. If you slide the magnet across the fridge, the resistance you feel is not friction alone. It is the magnetic field resisting change. The field prefers certain arrangements, and moving the magnet forces the field to reshape itself. That reshaping requires energy, and your hand provides it. Again, the space between the magnet and the fridge is where the real action happens. The field responds instantly to motion, adjusting its shape and strength without delay. Another simple example appears when a compass is placed near magnets. A compass needle is itself a tiny magnet, balanced so it can rotate freely. Under normal conditions, it aligns with Earth's magnetic field, pointing north and south. But when magnets are brought close, the needle begins to move. It sways, turns, and settles in new directions. Nothing touches it. No strings pull it. The motion comes entirely from the magnetic field in the space around it. As the needle moves through that space, it follows the direction of the strongest influence. Its motion traces the shape of the field without ever making it visible. The needle becomes a messenger, revealing what the eye cannot see. As the compass moves between magnets, its behavior changes depending on position. In some spots, it turns sharply. In others, it hesitates or settles into a steady angle. These changes show how uneven the magnetic field can be. The space is not uniform. It has structure. That structure guides motion with precision. The needle responds instantly to even small changes in position, showing that the field is sensitive and continuous. All of this leads back to a simple truth about magnets and the space between them. There is no solid object filling that gap. No hidden material floats there. Yet the gap is far from empty. It is filled with a magnetic field, a pattern of force that determines how magnets behave. Attraction and repulsion do not come from contact. They come from how fields interact in space. When two magnets affect each other, the real exchange happens in the invisible region between them. That region carries the instructions. It tells the magnets whether to move closer or push apart. The magnets obey because the field defines the rules. Between two magnets, it is never about emptiness. It is always about the interaction of fields shaping motion in silence. Even though nothing can be seen between magnets, the force is real, steady, and powerful, working quietly in the background every time magnets pull or push without touching. That invisible space is not empty at all. It is alive with magnetic influence, shaping motion and balance in ways that often go unnoticed. If this force has ever surprised you or made you curious, share your magnet questions in the comments and join the conversation. If this video helped you see the hidden side of everyday science, show your support by liking it, sharing it with others, and subscribing to the channel for more simple explanations of the unseen forces that shape our world.